Recording. All right. Hi, everyone. Welcome to today's class. This will be our last lesson in this series of 7 classes. And today we are going to be talking about what comes beyond, because we have covered pretty much all of the technical content of this class um, simply just using MIT App Inventor. And I think at this point, you're all now ready to start thinking about what comes next after MIT App Inventor and how you can further develop your skills in machine learning and artificial intelligence by using Python. So today, even though you may not have any Python background, we will be going through step by step how we train models, how we test models, and even how we deploy models so that once um, once you're ready for this kind of stuff, you'll basically know the sort of steps, and all you'll have to know are the syntax elements, and those are pretty easy to pick up. So let's dive right in. There's not really going to be much of a lecture component today, except for this reminder of the machine learning pipeline, because this is going to serve as the foundation of everything we're going to be doing today. Um, So yeah, let's go through it and see if some of these terms remind us of things that we talked about before. So it seems like, first of all, this is a cyclic diagram, meaning that things are sort of looping into each other, and that's sort of representative of the iterative nature of machine learning, where you continually build models, and if the models are bad, then you just try again and you build better ones. So let's just ignore the cyclic connection for now. Let's just imagine that there are no cyclic connections, so these two edges don't exist. And that means that this is going to be our start. It's going to be the start. So of course, when we are formulating any machine learning task, we need a bunch of data, right? Because the whole point of machine learning is to give a model a bunch of data and ask it to understand something about the data. So of course, you're going to have to prepare your data. And this is usually a pretty expensive part of the process. Expensive. Because not only do you have to collect your data, which sometimes might be expensive, you might face regulatory issues. For example, if you try to obtain medical data. And then of course, then you have to actually label the data, which is very, very expensive. It requires humans to go in and label the data so that the computers can learn from humans. But again, takes a lot of man hours. So then after you have data preparation, these two things are, I think, tied together pretty closely, because when you collect data, you also have to keep in mind what features you want to be using. But feature extraction is sort of the quote unquote next step. And this one is super important. Remember, we talked about we've talked about this throughout the class, but feature extraction is the method of simplifying this very complex problem. Because let's say that you're trying to model, I don't know, let's take another example. Um, let's use images today, because we're going to be using images. Let's say that you're trying to model, you're trying to predict something from somebody's brain scan, or predict something from someone's MRI. For example, if they have a fracture in their bone or something. Um, Without doing any feature extraction, the pixels on the image don't really mean anything to the computer again. So that's why we have to use convolutional neural networks to extract the right features. In other cases, if we don't use convolutional neural nets, for example, if we were just trying to do some classification, like classifying which flower is which, as in the case of the iris dataset, we talked about this at the very beginning of class, well, then you're going to have problems if you choose the wrong feature. For example, if you choose maybe the color of their you know, their stems, they're probably all going to be green or something like that. So instead, you want to be choosing on features that can actually yield some discrimination between the classes. So the sizes are different, the colors are different. So then based on that, you can make a much better prediction than if you just had 50-50 split features. So these two things are both things that we need to consider before we even think about start creating a model. And then we have some data, right? Then we have to define our model. This is also a super important part. Because remember, we've talked about a bunch of different types of models so far. And if you choose the wrong type of model, then you will be making the wrong type of hypothesis, and therefore you might be getting a model with very poor performance. For example, if you're trying to measure something that varies inversely with the input, so maybe y, x, maybe this is what you're trying to model. And what happens if you use y equals beta 0 plus beta 1? Well, you're never going to get really close to this. Maybe the closest you can get is a straight line that has a negative slope, but this doesn't really capture the nuance of what's happening when this function dips below the line. So this is not good. So if you choose the wrong hypothesis, then you are doomed to fail. But in other cases, for example, with neural networks are such strong and rich models that they contain too many hypotheses for the correct model. And so, you got all these connections, and neural networks are actually way too good at fitting data, such that sometimes they do what we call overfit. And so it's not necessarily a problem that you choose a model that's more complicated than your problem, but then in your model training step, you have to be very careful not to let this model overfit. There are some tricks that we use to avoid overfitting, avoid overfit. And what we do is we call regularize. This is more of an advanced topic, but just remember that for hypotheses that are too rich and too complex, you will need to make sure when you're training the model not to allow it to overfit to the data. If you get, again, using this inverse relationship thing, if you get a bunch of data, you might see this sort of trend where it's not perfectly a 1 over x line, but it's close enough. So a good fit to this data would be this 1 over x line. But if you make your neural network too complicated and you fail to regularize it, then you will get something really jagged. It'll try to hit all the points. And this is bad because then you're not really accounting for the underlying distribution. You're actually picking up on too much of the noise. And this sometimes can yield very wild predictions. An extreme example would be if you had a point up here, then your model would try to hit it too. And this clearly breaks the 1 over x relationship that we observed. So yeah, very complicated models are super prone to overfitting and prone to getting messed up by outliers. All right, so you have model training. And then, of course, to make sure that your model is doing just fine, you need to test it. So whenever you create a data set, this is basically the constructing a data set part. Whenever you construct a data set, you want to use some of the training, some of the model, some of that data for training. In fact, most of it, usually maybe 80 or 90% of it. And then you want to use the other 20 or 10% for testing. So this is the train test split that we talked about maybe on the first or second day. So, and then of course, once you use this data, you've trained a model that you choose to be appropriate. Usually neural networks are a fine choice. And you've tested it to make sure that it works well, then you can deploy. This arrow represents deploy. So you can deploy it out into the real world and you can have it make predictions on new data it's never seen before. So this is the machine learning pipeline. I hope that a lot of this is very familiar to you all because essentially each day we've covered a different part of it. And then we've especially spent a lot of time talking about different models, right? To choose the right model is very important because, again, you want to use a model whose set of hypotheses are very suited to the data, right? For example, images are not suited to this kind of neural network. They're much more suited to, not suited, they're much more suited to convolutional neural networks because of the properties that we talked about: spatial locality, translational invariance. Those are things that we want in a model, and those are provided somewhat by a CNN. So there we go. Hopefully everything's sort of starting to come together. Now, these arrows here, they represent what the process is to achieve all of this, right? So we first start, and so if you ignore these two things, then you'll notice that all of our nodes are acyclic, so we can sort of figure out which one we need to do first. So first we need to do data preparation, then we need to extract the features from the data, then we need to define our model, Step 3, we need to train our model. Step 4, we need to test our model. Step 5, and then we need to deploy our model. Step 6. So all of these steps are crucial to any machine learning pipeline. And up until this point, you have not gotten a lot of experience with steps 1 through 5, right? This is all a big question mark, I think, to most people, because when we've worked with MIT App Inventor, the models that they've given us are already pre-trained. So this is basically our homework. MIT AI2 gives us pre-trained models. But the real question now is how to train your own. And to a certain extent, you did some of this, right? When you were doing the personal image classifier, you were collecting data. So maybe you had some experience with part 1, but for sure, parts 2 through 5 are at best a little bit hazy. Like maybe you can see that the personal image classifier ran all of these steps behind the scenes, but how really do you implement this kind of stuff? And so to answer this question, we're going to need Python. Unfortunately, MIT App Inventor doesn't expose all of the components of the machine learning pipeline that we need to do this kind of stuff. And so therefore, we're going to be working in Python today. Again, do not worry if you don't really have a grasp on Python. You might not even know what Python is. But I thought it would be interesting for you all to see what's coming up for you, because I think after this course, since you're all now so well versed in MIT App Inventor and you know how to build apps, it might be time to move on to Python, to learn Python and to learn, well, first learn Python, and then you can learn ML frameworks in Python to actually accomplish whatever you want to do. And today, we're going to be covering both of these things. I'll sort of explain everything in detail, but in the future, you'll be able to do this yourself with what you've learned from this class and what you will learn down the line. So does anyone have any questions about this machine learning pipeline that we're going to be walking through today? If not, throw a thumbs up in the chat. Okay, wonderful. So it looks like, okay, great. So we are officially done with lectures. And so now we will be working on some code. Now, we're going to be coding in Python today. So I don't expect you to have Python installed, and I don't expect you to implement this along with me. I think the best thing that we can hope for is that you can look at the screen and we will be talking through everything. If you ever have any questions, you need to let me know so that I can help you out. This can pertain to syntax if you're curious about what something does, or just anything that's conceptual. So if anything where you're not sure what we're doing, well, I'm here to help you with that. All right, so let's get started. So we're going to be working in Python. Let me zoom in. And in fact, I think it might be a good idea to work in a notebook because, just because it's easier to visualize everything. So let's create a new notebook. If you know Python already and you want to follow along, feel free to. You can use this thing called Colab, Google Colab. They give you free GPU instances. Very nice. And we're just going to name this MNIST project. And the reason we're going to be doing this is we're going to be working with the MNIST data set. So eventually, what I have planned for the homework is that we're going to be implementing the entire machine learning pipeline in class today. And then for your homework, you'll be integrating this with MIT App Inventor. But the catch is that it's not quite as simple as you might think, because today we're working with images. We're working with MNIST, and I'm still working on this, so I will give you guys updates once I figure it out. But I believe it is possible to interface this kind of image data with an API. And so stay tuned for that. Anyways, this is the data set we'll be working with. It's called MNIST, and let's get started. So what is Python, right? Python is a programming language. And what's beautiful about Python is that there's a huge community of people who have built packages for Python. And as a result, you can simply just use this thing called pip. It's just like an installer. It's sort of like an app store, if you will. You can just use pip to install a bunch of things off of the internet. You don't have to do any weird downloading. You don't have to be messing with, header files or whatever, or jar files like you do with Java or C++. All you have to do is run this command and it'll download all the code that you need from the internet. And people have written some pretty crazy code. Like one example is TensorFlow. TensorFlow, you can simply download just by typing in install TensorFlow. And TensorFlow is a machine learning framework. Remember, we talked about Python, and then after you learn Python, you need to learn a machine learning framework. Well, this is the one that we're going to be using today because it's so easy to get started with. And so once you've installed it, and this online session that's hosted by Google Research has already installed it for us. So all I have to do is call import TensorFlow, and this gets all of the packages. So I'll write a comment here to describe what's happening. Download all the external code that will need to run the project, right? So all the external code that we'll need. So TensorFlow is the machine learning framework that helps us manage data and train models, right? So that's one thing. We're also going to be importing NumPy. NumPy is like a scientific computing framework for managing numbers. It's very general purpose. It's basically a very quick way of manipulating a bunch of numbers. They have a bunch of cool algorithms implemented already, so you can just call them. And then this is pretty much it. And then I'm just going to set a variable here called k, and I'm just going to make this tensorflow.keras. So TensorFlow is a machine learning framework, right? And it has this submodule called keras, and keras is a super simple package. Is a package that makes it super easy to create and train neural networks, and it uses TensorFlow. And so we're going to be setting a variable called k to this module, so that next time we call keras, we just need to do k dot whatever. Now, just a couple of notes here. I'll probably start to move faster in a bit, but we have some time to explain things. When you say as, we're just saying this name is too long. I want to shorten it. So every time I say TF, I'm actually referring to TensorFlow, and the same thing with MP to NumPy. And this is basically also an alias. I'm too lazy to type in tf.keras every time, so I just want to type in k. Now in Python, when you set variables, it's with the format var name is equal to var value. So in MIT App Inventor, what you would see as this initialized local variable to, what I just wrote there would be equivalent to var name. This is the variable name, and then you would set it to some value here, variable value. So these two things are in fact equivalent. All right, hope this makes sense. So we've done our imports. Let's add some text here. We can add some context. Whoops. We can say that this is imports. Imports. We have imports, so that's good. Then the next thing that we need to do is perhaps get our data, right? So let's create a text box here, and we can be like, get our data. So we want to be using the MNIST data set, right? So the MNIST data set happens to be preloaded with keras. If you just go to keras MNIST, you'll see that keras has a data set here called MNIST, and they've already loaded it for you. MNIST is such a popular data set that they've already just put everything in here. And this is the code that they tell you that you can load the data with. So let's just go ahead and use it. We copy it, we paste it. We realize that we set k to tf.keras, so this should be just k. And if we run this, oh, well, I forgot to run this first part. And then now we run this one. Huh? K is not defined. Ah, there we go. So it's going to be downloading all of the data, and it's just going to be done. So what happens if we print one of these things? So first of all, notice that this is get the data. And also notice that we currently have a train split is first, then we have a test split. So remember, this is super important. You have to reserve a portion of data for testing and another portion for training. And if we wanted to figure out what is happening inside here, we can print one of the training examples. We just print the first training example. Remember, Python is 0 indexed. So this means get the first training example. This is basically like select list item. So if you were an MIT app inventor, you go to lists and you're like select list item in an index. This is basically what that's doing. It's selecting the first element out of X trait. Now, if we print it, you'll see that it's just a bunch of numbers, right? And it's a little bit confusing. So one thing we can do is we can import a package that lets us visualize this thing. So we can import the plotter, we can show the image, and we can do plot.show. If we do this, there we go. So we can see that this should be a 5. And this is a bit of a stretch, but does anyone want to guess what I should do if I should try to check if it's actually a 5? What would I do? Like, what if I wanted to know what the actual label was for this image? If anyone is adept enough at Python. Or just conceptually, what would I do to get the label? Yeah, that was a bit of a stretch, but because we have the first element of X train, then we also know the first element of Y train corresponds to X train. So what I can do is I can do plot.title, and I can be like Y train 0. And so we hope that this plot will not have a 5. And indeed, there we go, right? There's a 5 here, and it looks like a 5 to me. So we now know that these images represent a bunch of these. Every single array of these numbers represents a single pixel, a single image, and each element in the array represents a single pixel. So let's not print it. This is kind of annoying, but sure, we can keep the plotting in here. And we can also move this back up to our import section. This is a plotting library. All right. So if we run this again, it should just give us an image. All right, great. So now we know MNIST is fine. It's just a bunch of images of stuff. So we have our data now. Good stuff. Then we have to go and do our next thing, which is create our model. Today we'll be using a convolutional neural network. All right. So to define our convolutional neural network, Keras makes life super, super easy for us because we can use a what is called their sequential API. So we can say that my model, this is just a variable name, and we're going to set it to k.sequential. Sequential basically means we're going to give it a list of layers. And we can give it a list of layers, and it's going to add all of these layers into a sequence into a model. So today we'll be using a convolutional neural network. Does anyone remember what types of layers are inside a convolutional neural network? Just list them out. I think there are 3 that I'm looking for, or 4 that I'm looking for. Any thoughts? What types of layers go into a convolutional neural network? We covered this on Wednesday. So there's a suggestion in the chat. Okay, so I see something that's very, very good. So one student suggests convolutional layer, pooling layer, fully connected layer. So you're almost there. We're missing a the activation that comes after pooling, but that's pretty much a very minor detail. So yeah, this is absolutely correct. You have a convolutional layer, pooling layer, fully connected layer, and then of course activations in between. So the way that we explicitly notate this in Python is Keras has all of these layers implemented for us. As you can see, k.layers.conv, you can select any of these convolutional layers. You can 1D, 2D, 3D. Let's just go with 2D for now because our image is 2D. And we're going to need to specify a bunch of things. So does anyone remember how we can specify a convolutional layer? What are the hyperparameters of a convolutional layer that we can choose? The docs are sort of giving them away, but it's okay. Well, remember that we have a bunch of different ways that we can construct our kernels, right? One of the ways is we can choose how many kernels we want. If you look back on the lecture, that's how many kernels we want. We can also choose how large we want our kernels to be. And so the way that we denote this in Python is when you count the number of filters, this tells you how many kernels you want in each layer. You can choose some arbitrary number. I'll just go with 16, maybe. So we will apply 16 filters to this image. We need to define the kernel size. I think I'll define a 3x3 kernel. And that's pretty much all I want to specify. Then we can do k.layers.maxPool. We can do pooling in 2D. We can do a 2 pool size, which is the standard. So we would be we would be using a 2x2 pooling. Then we would go to k.layers, and then we would add a value right here. This is an activation function. This is an activation function that serves the same purpose as sigmoid. It's not exactly sigmoid, but it's an activation function. So they have the same purpose to squish your function so that it's a nonlinear. Okay, so remember in a convolutional neural network, we can have many, many of these sequences. Because MNIST is a little bit simpler, we'll just have 2 for today, I think. Then we can use 32 filters. The standard is to make these filters deeper and deeper. So the first time we use 16 filters, the second time we'll just use 32 filters. I'll keep a kernel size of 3, and we'll keep everything else the same. So after the convolutional layers, does anyone remember what we do before we put it into a fully connected layer? And if you don't know, just type in "don't know" so that I can sort of gauge where we are. So in fact, remember that once you do all this convolution, what comes out is sort of like this block of numbers. You'll get a really deep block. In this case, we'll get a 32 deep block. And since you're reducing the size of the image each time because we're not doing any padding, it'll probably come out to, I don't know, maybe about about 20 or something like that. We can even use a larger kernel size. We can do a 5 by 5 kernel and it'll come out even smaller. But you'll get this 3D volume of numbers. What then you need to do is to do k.layers.flatten, because to process this in an artificial neural network, you have to flatten all of your volumes into a 1D line, so a 1D array of numbers. And in this way, you can actually put it into an artificial neural network. So then we call flatten, and then we can use a bunch of dense layers. So dense layers are the fully connected ones that are at the end of the convolutional neural network. We can make it like 100. We can use a value activation. And then finally, at the very end, we do k.layers.dense. And then how many output neurons do we need? Does anyone want to suggest a number? So how many classes are we trying to predict here? So there's a suggestion in the chat that says 1. So sure, but why do you think so? Like, maybe this is a little bit misleading. We only plotted one of them, but here's what we could actually do. Plot that subplot. We could do 1, 1, 3, and then for I in range 3, we can plot that subplot. Oh, wait. Plot that subplot 1, 1, 3. Actually, plot subplot. Okay, yeah. It should be 1, 3, I plus 1. And then we can do this. So if we do this, we should get, whoops. There we go. You can see that the more that we do this, we can choose actually a number here. We can say like 10 if we wanted to. You can see that if you wanted to do this, you could print out all of these different things. And of course, this is randomly sampled. So all of these, this could contain not all the classes. But how many classes do we have? How many possible digits are there in base 10? Yeah, exactly, right? So we're going to be trying to classify numbers into 10 different categories. Great. So this is our model. And if you think about it, this corresponds pretty well to a convolutional neural network. So if we pull up a diagram of a convnet and we compare it to what's happening here, and this is exactly a convnet for the problem of MNIST. Let me just copy the image address and we can insert it here. Oh, maybe not. Let's insert this. Oh. Okay, well, maybe it's not so easy to insert. Okay, there we go. It's gonna look weird. Wait. Okay, so this is our image, and you might see how this corresponds pretty closely with everything that's being shown here. So at first we defined a convolutional layer with max pooling and ReLU. So in fact, they used a 5 by 5 kernel. We used a 3 by 3 kernel. It's fine. They didn't specify how many channels they have, but we're just gonna roll with 16. Then they did 2x2 max pooling, which is exactly what we did here. It reduces your size, well, each dimension by a factor of 2, so the entire thing by a factor of 4. And then you have another convolutional layer, so exactly another one. We happen to have the same thing here because it's a 5x5. We also used a 5x5 kernel and then 2x2 pooling. And then we flattened it just like they did. We called flatten. This flattens everything. And then you can and then you pass it into a neural network, and then it all goes through into an output. And 0 through 9, if you count, is actually 10 numbers. So what we did here is very, very similar to this image that is shown here, which is a good thing, because apparently this is a good way of constructing neural networks that can learn properly for this purpose. All right, so we have our model defined now. Our next step is going to be training. So we're going to be training the model. The syntax for this is maybe perhaps a little bit seemingly arbitrary, but it's okay. What we do is we call myModel.compile. This allows us to pass in some parameters about this model to Keras and to TensorFlow to tell it how we want it to be trained. We have to first tell it which optimizer we want. So we'll just be using Atom. This name might sound familiar to you. It's just a very popular algorithm for finding the optimal weights, the optimal parameters of a model. Then you have the loss, which is k.losses.sparse categorical cross entropy. This is a loss function. Basically, it's the function that tells the model how bad it is so that it can figure out how to be better. And then, of course, there's the metrics. We want the accuracy. So k.metrics.sparse categorical accuracy. Don't worry too much about what sparse means, but just know that it is looking at something that pertains to the categorical error of your model. And cross entropy is the name of the loss, and accuracy, of course, is how accurate you were when you were classifying. So we want to track this metric. All right, so we've compiled the model. Let's go ahead and run this cell. We've compiled the model. So now the model, Keras knows these are the parameters that we want to use to do things with it. Then all we have to do now is say myModel.fit. And when we call .fit, we have to pass in the data, right? We have to pass in X train, Y train. We're going to do a validation split, which is a holdout. So we take 5% of the data, we hold it out, we don't show it to the model, we train the model on the 95% of that data. And then while it's training, we're going to do some evaluations on this 5% holdout set so that we can make sure that everything is progressing smoothly and the model isn't prematurely overfitting. All right. So this, and then finally, after we run this, we would call myModel.save, and then we would call it maybe trained MNIST CNN or something like that. All right, so this is the model. There are a couple of details that we have not addressed yet. First of all, is in the data, if you look at the data, so let's insert some code here. If we print, or actually let's do it down here. If we print np.shape, which tells us the shape of the tensor or shape of the array, whatever you want to call it, of X train, it'll show you that it's 60,000 by 28 by 28. What this means is that there are 60,000 images in the training data set, and they're all 20 by 28 images. Now, because of the way Conv2D works, or just the way that it's implemented, it actually requires four dimensions, so to say. And this fourth dimension is the number of channels in the image. So in this MNIST data set where everything is black and white, how many channels do we have? So we have a suggestion of 2. What might make you think that? Sorry, channels as in the number of color channels. So perhaps I can imagine where this number 2 came from. Maybe you're thinking black and white, but actually these two variables are completely dependent on each other. So if something is 80% white, then it's also 20% black. So these are complements of each other. And you can actually represent everything that's grayscale on a scale of 0 to 1 in one channel. So the correct answer is one channel. So now we have suggestion of 4. So actually, the dimensionality of your big array here is not the channel. The channel is how many color channels do you need to represent something. Like a regular image, you would need 3, right? You would need R, G, and B. But if you're talking about grayscale, then you simply just have to specify how bright each pixel is on a scale of 0 to 100%. And that's simply one channel of data. So this problem of channels is going to be important because TensorFlow actually expects, TF expects a shape of 60,000, 28, 28, 28, 1, where 1 is the channel. Now, these two things are actually equivalent because if you just make a 1 here, you already have one channel here. These are the same thing. But just because TensorFlow's implementation relies on the fact that there is a channel here, we need to specify that there's another channel. So the way that we would do this is to do ... none. Don't worry too much about what this means. You'll learn about it when you work with Python. This is just a way of slicing things. Whoops. And because we want to visualize it, and the visualizer doesn't really play well with, or maybe it does, I don't know. Oh, wait. This doesn't make sense. We can't set this variable. That's my bad. Okay. Well, we'll collect the data, and then we will say down here that x train is equal to x train, and then we're going to do ... none. We're also going to do x test is equal to x test : none. And now if we print the shapes, you'll get that it's 60,000, 28 by 28 by 1. And this is, in fact, the format that is required. All right. So this is going to be so this is called what we call reshaping the data to conform to TF input standards. So there's also a message in the chat: when it's black and white, everything is just some amount of black. White is no black, gray is some black, and black is just fully black. Yeah, exactly. So this is precisely why we only need one channel, and that this is a good answer to the question. Yeah. So, and as with all things in life, you can be less efficient than optimal. You could specify 2 variables, both black and white. So you could tell you could be like, oh, okay, so this image is 80% black and 20% white. But this is not really efficient because these 2 variables are completely dependent on each other. They, if you know the value of one of these variables, then you know exactly what the other one is already. And because these 2 are basically equivalent in the information that they give you, there's no reason to keep both of them. So you just need to choose one. You can either choose to say how black an image is or how white an image is. And so I think Tianxin's response or explanation is perfect here. All right, so we have the shape being reshaped correctly down to 2028-1. And yeah, this should do it. And then there's also one more final thing. If you'll notice, if we print out one of these things, if we print out x train again, we print out the 0th one. And we should probably do this in the next code slot. If we print it out, you'll notice that it's a bunch of, okay, there we go. It's a bunch of zeros, and then there are a bunch of these huge, like, triple-digit numbers in here. And this might not look, it might not be obvious what exactly this is to you, but if I tell you that the range is from 0 to 255, this might ring a bell. Does anyone know what is the significance of this number in 255? Yeah, 255 is a color number. In fact, I believe that 2 to the 8 is 256. So this is actually an 8-bit color. This represents in 8 bits, the maximum number that you can represent is 255. So if you ever go on like Adobe Photoshop and they're saying things about like 8-bit colors, this means that every single channel RGB is represented from 0 to 255. All right, so apparently they're using 255 as the maximum here. Now, it has been shown empirically that that machine learning plays a little bit better when you have your values normalized from 0 to 1. So all we have to do is basically divide this by 255 or 256. It doesn't really matter. Since the maximum value is 255, we usually just divide by 255. And if you divide it by 255, you'll notice that everything is between 0 and 1. This one gets really close. I believe its value was like 253 or something. And we want to do this for all of the training examples. So in fact, what we can do then is just to say x train is equal to x train divided by 255. Or in more simple terms, we could just do divide equals 255. And then x test is divide equals 255. So all of our inputs have been normalized now, and we can actually check what the maximum is by using this np.max thing. And if we print this, we should see that our maximum is either 1 or like 0.9 or something like that. Uh-oh, we have an error. No loop matching the specified signature and casting was found. So it looks like we might have to do this, but that's okay. Just a little bit more verbose. All right, so as you can see, we've normalized everything. We've printed out the maximum. Everything has a maximum of of 1. And then we can just say here that this is normalizing all the pixels to be between 0 and 1. All right, so now if we print x train, if we pick some random number like the 200 to 2462nd thing, you can see that everything is just between 0 and 1, which is a very good thing to see. All right, so now we have all of our data defined. We have everything defined. We can go into our runtime, in fact, change our runtime type, and Google Colab is kind enough to give us GPUs for training our models, which makes them very, very fast. And then we can do restart and run all. And then this should, in theory, give us a model that works. And we can follow along the outputs. So it's downloading the data. It's displayed all these random things. It's normalized everything to 1.0. It's creating our model. It's training our model. It's now training our model. And it should be outputting things. I can change the argument for verbose to like 2 or 1. Uh-oh, is it not responding? Well, it's not responding to interrupts. Would you like to, no, it's okay. Interrupt execution. Okay, and then let's try this again with the verbose argument. Okay, there you go. As you can see, the model is training. The categorical accuracy has already increased to 95%. And the validation, which is the data that this model has never seen before, it's already 98%, even after the first epic. We actually only did 1 epic, so let's do like 10 or maybe 5. Just for reference, an epic is, ooh, it doesn't know what that means. Okay. Oh, I think it's epics. By the way, epics is just given a data set, you run backpropagation on this entire data set once. That's 1 epic. Then for the model to actually converge to a good solution, you might have to do this multiple times. In this case, it looks like to me maybe 5 will be enough, but it really does depend on your specific situation. So at 3 epics, we're already at like 99.0% accuracy on the validation set. And then after epic 5, we have 99.3%. So that's pretty dang good. And I asked it to save the model at trained MNIST CNN. So if we go to our files here, we should be able to see that trained MNIST CNN is here. So now we can hit, can we download this? It would be unfortunate if we can't download this. Um, Weird. Can I drag this to my computer? Nah, it's not gonna work. Okay. Um, it is okay because I can train this on my local computer as well. Anyways, um, yeah. So hopefully this gives you a good idea, some insight into how models are trained. Let's just go through everything one more time. So at the very beginning, we imported a bunch of packages. This will download all the external code that we'll need to run the project. I can put this in the markdown, actually. So it downloads all the external code that we'll need. We got the machine learning framework. We got this scientific computing framework. We got a plotting library. And then Keras is just a sub package of TensorFlow. And I was lazy, so I just set an alias. And then to get our data, there's this really nice function that loads our data for us. This isn't always the case when you're designing your own models. So just be thankful that Keras is kind enough to help us out here. So we got our data. It downloaded from somewhere on the internet. And we wrote this code to visualize it. So in fact, if you wanted to do 20, you could do 20. And then you do 2 times n. Oops. Okay, yeah, it's not happy. Let's restart. And anyways, we got all this stuff. We plotted it. We saw the pictures. They sort of corresponded to the labels pretty accurately. Like, see, now we have more examples. We have almost all the numbers, I think. So you can see, you can visualize the data set. Then we did some, I think we can add a text blocks here because this is a little bit different. This is called image pre-processing. And this is where we, this is basically where we modify the images slightly to better fit a model or something like that. So we did image pre-processing. We created our model, a convolutional neural network that looks a little bit like this, but a little bit different. You could play with these numbers if you wanted to change the number of filters or your filter size. And then finally, we trained our model using this compilation method to tell Keras how we want to train our model, what kind of parameters we want to feed it. And then we actually just called my model.fit or whatever it might be. And then we saved it. Does anyone have any questions here? So this is the first part of today's lab. Oh, so we have some people who are following along. We have some time to debug syntax errors, maybe. So it says that it's on the last layer, but it probably isn't because this is a list. And if you have an error anywhere in the middle, you will have an error. What's the syntax error say? Can you send your code block then? Yeah, you're missing commas. Make sure that you have a comma after the second to last layer. All right, no problem. Okay, so pretty interesting that people have been following along. That's pretty nice. So yeah, this is the first part, right? And if we think back to our machine learning pipeline, we have done the following things that we have pretty much never done before. We have prepared our own data. This is, we've already sort of done this before, but we did feature extraction. And sort of in between here is this idea of image processing or image pre-processing that we've never really touched before. But this is super important, as we talked about. In general, it's much better for models to get numbers that are between 0 and 1. In other cases, you might standardize them, which means subtract the mean and divide by the variance to basically find all the z-scores. That standardization sometimes helps, and a whole slew of other things. There's just a lot you can do here. Or in general, this would be, or more generally, this would be data pre-processing. Now, we did this We did model training. We created our own model from scratch. Well, not really from scratch, but we defined all the parameters of the model. We didn't just let MIT App Inventor define all of them. We did model trading. We used test data on what we called the hold out set to the set of data we used to evaluate the performance to make sure that the model wasn't simply just memorizing things. And then finally, we have this component here called predictions. This is the deployment aspect that we have not talked about. So we now need to deploy our model. All right, so this is what we're going to be working on next. So we have this this thing, right? And we've saved our model. It should be here. I can't download it, but luckily I have. Oh, so you can only download files. That's pretty lame. Okay, so we have all of this. We have this folder. I happen to already have a model that works on my own computer, so I will just work from my computer from now. And to deploy it, we need to use some kind of library that can help us deploy such a thing. So how do we do this? We need to use something called Flask. So Flask, I don't know if I can pull up a diagram of Flask. Python Flask. Maybe they don't have any diagrams. Yeah, this is not very helpful. Well, I'll just sort of do some drawing on an empty slide, I guess. So Flask is it's yet another package. So it's much like TensorFlow and that the other packages that we imported, in that you can simply just download it from the internet, and you could just use that command pip install Flask and it'll just download it for you. And what it does is it creates this interface between your backend code and whatever user is trying to use it. So imagine that you're a user here and you have an image, and imagine that you can't read. So you have an image here and you want to know what this image is. It's on your phone or something. And so remember that the other day we talked about APIs. So we go, our user, let's say that this is a cell phone, you send an HTTP request. It's usually post or get, but since you're working with images, it's probably going to be post. So you post this image to a web server, and this website is here. It's got some computer here. You got a computer here that can do something. I don't know, it's supposed to look like a microchip, but you got a computer that can do something. So then the cloud sees your HTTP post, the image is all here now, and then it'll go to whatever location it is that that it references to. So then the cloud will redirect your traffic to your personal laptop, or this is my laptop here. This is Kevin's laptop. And it doesn't really matter. This doesn't have to be my laptop. It could be some hosting service, somebody that hosts my code for me, or whatever it may be. So you have a hosting service, you have Kevin's laptop, and then here is where the AI model, or in more specific terms, since we now know what it is, this is a convolutional neural network model, is hosted here. And so your computer will receive this image, then you will put it through your convolutional neural network. Then you will get a response. So CNN says that this looks like a 5. It looks like a 5, right? It looks like a 5. And then what it will do is it'll send it back to your cloud, and then the cloud will send it back to you. And then your phone will be like, this looks like a 5. So what does Flask do? Flask mediates this part of the pipeline. This is what Flask is responsible for. Flask is responsible for taking any sort of message that it gets between, let me just make this more obviously here. It's responsible for mediating any message between you and your specific laptop or your hosting service. and it sends messages. So on the inbound side, you would be getting a message saying, I want to classify a 5, and it gives you the image. And on the output side, your answer would be 5. So Flask is basically takes your AI model, it runs it, and then it can receive, both send and receive information from the cloud, and then the cloud will pass the information back onto your phone. So to be able to deploy this application, this part is going to be mediated by some hosting service, or some it's not exactly a hosting service, maybe not a hosting service, but a web service. It's basically just the internet, basically, that's connecting you and whatever server it is. Um, so this is just like the internet. Then you have Flask that is responsible for sending messages between your computer and the internet. And finally, you have the computer that's actually running the code. So in my case, I might be running it on a laptop, or in other cases, there might be a hosting service here. Such one is called Heroku. Heroku is one such hosting service for websites and stuff. And this is often a choice that people like to use when they want to host APIs. So you look at this diagram and you might be asking, why did I draw this out? Well, I drew it out to make it very obvious that there's only one part of the pipeline that we haven't really addressed yet that we need to, because the internet is already there. There's not much we can do about it. It's going to work. If you send an HTTP request, it will reach your computer eventually. And then on this side, we've already coded up the AI model. We already know how to get the prediction from some image. And we also already, the hosting service is going to take care of hosting everything to make sure that, your computer is running properly, that you can get the API up. So the only part that we have failed to do is to basically build out the part where you pass on messages between the cloud and your computer, where you can receive images and you can also send responses back. And that's what Flask is going to be doing for us. So Flask is actually pretty simple to use. So we can go ahead and start a new project with Flask. We'll be using a local editor for today. Computer's lagging. And we can go back to AI classes. Actually, yeah, maybe not. Okay. So let me just create a new directory here. We can make dir L7 mnist flask. Yeah, we'll just call it that, Flask. And we'll start up our code editor here. Not sure why my computer is so slow right now. Okay, so we're going to want to create a new file. We'll call it our app.py. It's just a Python file. And what are we going to need to do here? Well, of course, we're going to need TensorFlow, right? Because this API is going to be loading up our model on TensorFlow to do things. So then we're going to need to import tensor as TF, and we probably want to import NumPy. Oh no, my computer is so slow. TF, and then we probably want to import NumPy because it's just always a convenient package to use. And then we might also want to import Flask because I've been talking about it so much. We want to be importing Flask. And then, of course, we want to use our hack here, which is to say k equals tf.keras. This is like an alias. So the way that Flask works is that you have to initialize the application. So the way that you do that is you say app, call it variable app is equal to flask.flask. This creates a new instance. This is like a constructor, and then you pass in the name of your program, which is coincidentally called app. And you can basically use Flask to start listening at some URL. So, I mean, you're all very familiar with URLs, right? You go to a website and it's a URL. So if you wanted to go to youtube.com/watch you watch whatever it is, like some music video, some Mendelssohn or whatever it is, and this is like a URL that you're visiting. The thing is that when you're creating an API, you basically need to define what the URL is for your specific API. And we can call it whatever we want. The convention is to say something along the lines of maybe /API/predict or something. This would be like a typical URL name. So then if this was hosted on, kevinscoolwebsite.com, then you would simply go to kevinscoolwebsite.com/API/predict, and Flask would be listening right there to receive and send messages. So the way that we can package this into Python syntax is to go app.route, and you put this route in there. Oops, not predicts. And then you would define a function that's called whenever this thing is called. So you would do def predict. All right. And you can pass in some arguments to your API. So for example, if you went to again, kevinscoolwebsite.com/API/predict, you could pass in some arguments using the question mark. Remember, we talked about this the other day. You can use a question mark and you can be like, image is equal to some like value. And we'll talk about how we can convert images into strings later. But the way that you can get access to these arguments that people are passing is by using flask.request.args. And it's actually a dictionary. So if we just print flask.request.args, we'll be able to see something. And as a dummy, we'll just return, hello there, welcome to the API. We'll just return some dummy response. And finally, when this app is called, we simply just have to say if name is equal to main. This is run whenever we run this file. We just do app.run, and this will run the Flask application. So if we just go to our terminal and we come to app.py and we run app.py, what's going to happen is that it's going to deploy on this local server, this local IP, which is 127.0.0.1. This should, if you're a programmer, this will be very familiar to you. It's just your default local host, and it's going to be run at a port 5000. What this means doesn't really matter, because all you have to do is click on this link and it will say not found. The requested URL was not found on the server. Well, that's because we never defined a root directory, right? We only defined, we only asked Flask to be listening at this URL /API/predict. So to actually get anything out of this, we need to go to API/predict, and we would hit enter. And see, here it says, hello there, welcome to the API. And that's exactly what we said return would return. Just to make this easier to implement, to visualize, I think I'll just do this. So we can do split screen. But if I change anything about this API, if I pass in some data, I can pass in image is equal to, this is an image. If I hit enter, you can see that in the command line, it prints that there was an argument to my request that says the image, and its value is this is an image. So actually, what we can do is, first of all, we can ask, is the image being passed? Because remember, a sort of requirement where you call a predict API is you need to pass in something to predict, right? So we can say if data is not in flask.request.args. So if image, if you didn't pass in an image, this would be really bad. So you would return something like error, please send an image for us to classify. And you would return an error 400. So status 400 means bad argument, which means that you didn't pass in the correct argument. And then otherwise, you can return, welcome to the API, we got your image. So if we run this, I don't know if it quite, yeah, I don't think it refreshed. So I'm going to kill it and then I'll restart it. So there we go. Because we passed in an image, it says, welcome to the API, we got your image. And if I don't pass in an image, maybe I pass in the wrong name, maybe image with 2 G's, it'll be like error, please send an image for us to classify. So in this manner, we've sort of verified that the user is passing in some image. Welcome to the API, we got your image. So then we can do something with the image, right? Well, actually, there's something that we need to do. We need to load our model. This is going to be very important. So we're going to need to use K, or Keras. And in fact, the syntax to load models is pretty easy. It's just k.models.loadModel. And you have to specify where you saved your model. I think my model is currently saved as my model on my computer. And I need to actually retrieve it. So let's open our file explorer. My model is currently saved here. I created it maybe an hour ago. Maybe we can rename it to something a little bit cooler, like Amnesty CNN. So then we would change this to Amnesty CNN. And we would have to set it to a variable. Of course, we would say my, CNN, which is called CNN, is this model. So then you've loaded the model, and now you can do predictions with this model. And so at this point, this is pretty much the furthest that we can go without actually looking at MIT App Inventor, right? Because MIT App Inventor is going to sort of dictate that, however we can send our image over the internet is going to dictate what we're going to be able to do. So we're going to need to figure out how to build an interface in MIT App Inventor where we can draw stuff and actually send it to this API. And full disclosure, I haven't completely figured out this myself, so we'll be working together to figure out whether this is possible or not. And if it isn't possible, that would be sad, but I'm pretty confident that this will work. And even if it doesn't work, I think we've already gotten some really good practice in with understanding all the components of deployment. So currently, of course, as you might know, we are working on the predictions part. We've done steps 1 through 1, 2, 3, 4, 5. We have already done steps 1 through 5, and we're simply working on step 6 now. So for now, I think it would be good if you guys just sat along for the ride. Just you can watch what we're doing, and we can discuss in real time. But I probably won't have time to just let you guys re-implement all of this. So I'll show you what I've done so far, and then we can work together to figure out how we can actually send the stuff over the internet. So let's use our AirDroid casting. So then I can show you guys what I've been working on, and then we'll figure out whether it's possible to send the stuff over the internet. By the way, does anyone have any questions about Flask or anything that we did in Python yet? All right, so what I have so far is the following. I have this canvas thing. Let me just split my screen. I have this canvas thing, and if I refresh my screen, I can clear it. I'll add a clear button later, but I can be drawing a bunch of stuff, right? This is a canvas where I can draw. It looks really scuffed right now because everything is in terms of lines, and the line width is super large. But if I set it to like 5 or something, it'll look a lot more natural. So if I refresh the screen, as you can see, we've got something where we can draw lines. And this is not hard to implement if you're curious. Basically, whenever the canvas has been dragged, you just need to draw a line between the previous X, previous Y, and current X and current Y. All right, I'm going to delete the touched thing. The whole idea right now is that if you have a canvas, you do something with it. You draw something on it. Maybe you draw a character. Remember, we're trying to classify handwritten digits, so maybe we draw 4 here. When you click go, the whole point is that we can convert this into a string format, and then we can send it over the API, and we can figure out what classification it is and with some probability. So this is going to be the goal of today. So where have I gotten so far with this? Well, one way that we can represent strings in images in a string is called an image base 64 encoding. What this basically means is you take an image and you can actually represent it by a string of letters, a string of characters. And this is actually a completely faithful representation of the actual image. So our goal today is going to be to convert an image into base64 format. And it turns out that MIT App Inventor does not support this out of the box. Like apparently this is not supported. But I did some Googling, and there's this dude who made a really cool extension called KIO4 base 64. And what it does is it converts images into base 64 like you might suggest, like you might imagine. But the syntax for using it is a little bit confusing, and I haven't completely figured it out yet. So let's try to figure it out. Currently, we're drawing on a canvas, right? And our canvas, we need to extract the image out, and then we can call base64. So this thing, KIO base64, has this function called file to string, and basically it can read in some file and spit out the base64 encoding. So there's actually okay. So it says that you have to prefix the file name with a slash to read from a specific file on the SD card. Okay. To read assets packaged with an application, start a file name with 2 slashes. Okay, this is interesting. So it says that we need to do some things. And I think the key here is how do we save an image into a file? So there's this thing called canvas.saveas. Let's see, it stores it in the external storage in the file named file name. File name must end with one of these things, which determines the file type. So the real question now is, where did it save in my file? So if I hit go here, if I hit go, it should save this file in some location named mnist. So then I should be going to my file explorer and figuring out where this might be. So I will need to figure this out. Maybe it's in App Inventor, assets. Actually, what I can do is I can just search mnist.jpg. And it says no results found. That's unfortunate. Okay, so the forum here actually says that we can also do something else. We can use tinydb. We don't actually need the image, and you can actually pass in the file name. Okay, so when you take a picture, maybe it saves it into a file location, and then it says that you can pass in the file location to the string. So I think the critical question here is, where is this saving the file? And I click save, but it doesn't seem to be saving it anywhere. So we'll need to figure this out. All right. But anyways, after we get the string, we should be showing an alert that has the file string. But if you notice, we can try this right now. If we click text to button 1, it'll say that the file is not found. So clearly, I need to be finding where the heck this canvas is saving file name. So I guess one way to start from this is to look at what exactly is happening inside the canvas. So canvas, MIT App Inventor, and we can look up its documentation. So this saves picture of the canvas in the device's external storage. If an error occurs, the screen's error occurred event will be called, saves a picture of canvas in the device, the file name. And so MIT App Inventor Canvas, I think this one tells you how to save a canvas image. So let's see, it says it's save as, file name, it's going to save it somewhere. And okay, so you saved it, so what? And he doesn't really tell you where it's saved, so that's not good. file location of saved data files. I see. Okay, so it says that it's going to be saved to a location in internal storage. So it's going to be in internal storage, Android data. Interesting. All right, if I can't figure out this soon, I'll have to get back to you guys on this because
Yeah, I just wonder whether you can save it into the root directory, just the default root.
I mean, it should be storing it in the root. I'm not sure why it's not.
Oh, okay.
But I mean, we can try that. So like if I just use,
yeah,
if
can
I
you
put a
create
slash.
or otherwise create a directory under
No,
the
like
root?
it's not clear what this slash means. It usually would mean root, but apparently it doesn't.
Okay. All right.
Okay, so let's try this again. We might be able to find it after we force it to be an mnist. And then just to make sure that everything is working, I will show an alert. It says saved. All right, so we have our thing in draw 4, hit go, and it says we saved it. So then we can go into our files and let's see if it's saved. So it seems like my recent files doesn't contain it. We might need to search again, mnist. No results found. Problematic. Yeah. Okay,
Yeah,
it doesn't
when
seem
you
to be working.
when you retrieve it, can you put the what you call that? Is that a slash or backslash before the yeah, over here, right?
Let's see if this works. Yeah, it still says file not found. I will have to figure out what is happening here. I don't think it is worth it to waste everyone's time on this. But so here's the deal. We've already gotten very, very far, right? We've written up most of our Flask thing. The only thing that's left is to do take in the base 64 image, convert to a regular image, classify, and return the result. So this is what we need to do. MIT App Inventor is a little bit finicky and we can't really figure out where it's saved. It's not really documented well. So I will do some more digging and I will figure it out. And then I will post this on the master document. And so that way you will know how to convert everything into base 64. Then you can send it through the image parameter on the template that I will provide. And then I will deploy this application, the one that we wrote together, not the one that I wrote by myself, the one that we wrote together. I'm going to deploy it on Heroku, and it'll be up there. You can play with it. You can pass in your own images, and eventually, the whole goal is that you integrate this with your application so that you can send base64 versions of an image up to there, and it'll return the classifications. So you'll have like a cool handwriting recognition application on hand, which should be pretty interesting. I don't think this has ever been done before, at least not in the MIT App Inventor community. So that's why we're running into some issues, but I think they should be tractable. It doesn't seem like this is an intractable problem. So stay tuned for updates on that. But yeah, that is pretty much all I have for you today. We remember, just as a recap, we talked about the whole machine learning pipeline and all of the components that go into it. And remember, probably in all previous homeworks and labs, you've only ever interfaced with step 6 of the process, which is to build a model. Build an interface that can use the predictions, but you've never really seen how these models are created. But today with Google Colab, we have seen how we can build these models. through this whole process where we get our data, we do pre-processing, we create our model, we train the model. There are all a whole lot of these parameters that we didn't talk about that you can tune on your own free time. And given all this stuff, we built out a Flask API thing that can listen for a request that comes in from anywhere over the internet for predictions, and then it can accept image arguments. And then once we figure it out, we'll actually be able to accept base64 encoded images, decode them, return with a classification, and then you can build your own MIT App Inventor app that classifies your handwriting. So I think it's all very cool, and I hope it gives you a taste of what is to come, all of the exciting things that you'll be learning once you start dabbling in Python and the associated packages. But yeah, with that said, I just wanted to say thank you for joining us on this journey. I know 7 days isn't really a whole lot to be learning about a topic as vast as artificial intelligence, but I hope that it was useful. I hope that even if not everything clicked, that some of these terms have become more familiar to you, like features, labels, inputs, outputs, convolutions, recurrent neural networks, natural language processing, all the cool things that people can do. You now have a pretty good idea of how they're done, much, much better than all of your peers and even some college students that I know. Like some of my friends, they don't know as much as you do about artificial intelligence. So be proud of yourself that you've made it this far, and and uh, and yeah, I'll be handing it back to my dad. I think he has some closing words to say, but hope you
Okay,
had fun. Again, try to get in all of your homework on time. If you have any questions, I am available in the Discord, so feel free to
that's right.
contact me.
Okay, thank you, Kevin. Thank you very much. Uh, it is awesome. It is really a good class you have been teaching. So, okay, so today is the last lecture, and we're about to finish the last class. But the homework assignment will be due on future days. What I want to say is, it is important to submit all homework assignments. So late submission is much better than not to submit it. Okay, so remember to submit it. That's number one. Number two is I heard some students, it's hard for you to publish to the gallery. Oh, if the gallery doesn't work for you, you can download the project as a .aia file, right? And then you can upload the .aia file to the homework submission form. So you can submit as an attachment. So well, for this class, we have a certificate. I want to distribute it to you based on your attendance and homework submissions. So, well, what the certificate can serve as? Well, that's something that indicate you have finished this part of work. It's 10-hour. Oh, it's not 10 hour. It's a 14-hour lecture, right? And also, it can be served. I think it can be served as a discount coupon in the future if you take my other classes. So, but anyway, I hope that will be somehow something useful to you, right? All right. So the second thing I want to say is, some of you, when you submit your homework, you have some problem in deploying it, right? So when you scan the QR code, it doesn't deploy to your mobile app. So here is something like, well, I think we have already discussed it, but I just want to summarize it. What you can do, I mean, the steps you can troubleshooting or try to solve the problem. Number one, check whether the MIT App Inventor server, whether it is there is outage over there. Well, we recently noticed that there is like occasionally some outage over there. At that time, you won't be able to, to do the right thing, but just wait until it's recovered. And also there is another, sometimes, the extension you used we use extension, right? That extension linked to external components. Sometimes people also call it modules or packages or libraries. It depends on, it seems like different languages, they kind of use different slang. I mean, different terms, right? They're kind of exchangeable equivalent thing. I mean, that's external stuff that you can use, you can share and use it, right? So when that happens, if it is not compatible, if the external modules are not compatible, it's probably you're probably gonna have some problems in in deploying it. So that we should be aware of it. That's why some of the applications, especially in the artificial intelligence, people developed them using developed and tested using the Android, right? Because it's an open environment. So just make sure you use the right OS. Let's say Android. Well, Android devices are kind of recommended because it is more. Compatibility should be better. Okay, so one thing I'm not sure whether you can check is your current OS supporting your device or not, which means is that the device too old or what? If it is within 5 years, I mean, a device manufactured within 5 years, that should be fine. I think that should be fine, especially I think there was a lot of the MIT App Inventor developers, right? They tested a lot of environment, including Samsung, Huawei, Xiaomi. So they're all good. They go and also Amazon file 7 file. It should be fine. But just make sure your device is good enough. But I don't think that's a big problem. Okay, if it still doesn't work, you probably can reboot your mobile phone, right? Just trying to do that. Always rebooting sometimes solve problems. Debug is much easier than debugging or troubleshooting it. Well, if it still doesn't work, I think you probably can test one more thing. Just scan a proven working project from others. Let's say you got a shared project from Kevin, from your friends, right? Just scan on those and see whether it works for you. Because sometimes compiling error just prevents you from deployment, right? So, right, if all these doesn't work for you, I would recommend you try another mobile device. Just find it. I mean, like in my home, we have several Android devices. There's like old phones, old tablets. I mean tablets and old phones that try different things. If none of them works, the last thing is check. I think there is only like one project or two. I mean, very few of them you have problem. If you really have problem, I don't recommend you spend too much money and time figuring that out. As long as you can figure out how that works, and you learn something from that project, that should be fine. Just tell me in the homework and saying none of them work, and I watched a YouTube. Give you the YouTube links. Yeah, if the YouTube link can describe the whole processes and takeouts, I should be fine. I should be fine. I mean, for few projects, let's say. All right. So, okay. So what's in the future? Here are some the next. I will provide some suggestions and advices where you can go. So to me, there is two concepts. One is the strike. We talk about the strike in the learning rate, right, in the class. The strike is how much you're going to advance within one class. And the other is the displacement, which means how far are you from your original, your origin. I mean, where you start. Okay, I think Both are important. However, strike is something you do it within one class, right? But the displacement is something you make several steps and see how much displacement you have. I want to say ultimately we're going to focus on displacement. Okay, a lot of times we focus on one class, how much we learn from this class. Well, that's important, but the more important thing is how far you have advanced from some from some point of time in the past, right? So that's very important. What does that mean? That means you're gonna determine a direction to go. When you go along the same direction, the direction, right? Eventually you're gonna go very far. If you have a big strike on each of the whatever courses, and but the direction is kind of random, and that won't really lead you to go too very far. So that's what I mean. The direction. I've seen some good directions, and some directions are probably not this best time for you guys to do. I'll give you two problems which are I don't consider. I think there is some like a space to improve. One is someone told me he has taken like a 6 programming classes before he joined this class. I want to say, what did you? I mean, did you do something? What kind of things significant things? Tell me something like you're really proud of doing that. I think that's important, right? If you do spend a lot of time on different, the same level or whatever, random directions, I want to say find a direction. The other thing is someone told me he's in the East Coast, a guy, very, very smart guy. He told me I just passed the Java certificate, Java programmer certificate, right? Which is that certificate is for a professional, actually professional. Is that the right direction? Well, that is good for, okay, the Java certificate is actually, they dig into like a very in-depth like steps and the verbal knowledge about the Java, a lot of settings, a lot of parameters, a lot of all kinds of like functions, procedures to call the structures, that kind of thing. Okay, so what I want to say is that's good for work. However, as a student, we probably cannot consider even better directions. I want to give a suggestion is you can consider some of the 3 directions. One is the programming competition. The most famous is the USACO, USACO, right? United States of America Computing Olympiad. That's the most famous one. There is a lot of programming competition over there, like a Google, Facebook, even in our local, like a Kevin attended HP Code Quest and Lockheed Martin. There is a Cold War, something like that, right? That's one direction. The second direction is the science fair, right? The science fair, look at the science fair, no matter what subjects, like no matter it is a software, it is artificial intelligence and robotics, or whether it's engineering, biology, or whatever, there is a lot of projects doing with artificial intelligence. That's where you are studying. Yeah, this is absolutely, a great a playground for you to, to extend to many areas. Many subjects, right? So it's a science fair, and the third, but it's absolutely not the last. There is a lot of directions you can go, but I can recommend several of them. And the hackathon. Hackathon is a great place to go. It's a great place. Hackathon is usually does not give you a problem to solve, just give you a theme, a focus. But you can use your own creativity, right? Create a I create a novel idea and trying to design the cool stuff, and then you implement the prototype. It's when I say prototype, it's not a complete application, but it's a it can show your idea and see how your application gonna interactive with people and where you can use it, right? So a lot of hackathon projects they have, there is they are a lot of this kind of projects. They are adopted, being used in very, very famous product. For example, like the Facebook chat is one of the original, it was origined from a hackathon project. So, well, MIT App Inventor, they have an annual hackathon competition. It is for, there's no age limitation. They have 5 groups. You can team with people. You can do it alone. You can be any kind of. I don't think even they have like an age restriction. So just go ahead and do that. It's free. It's hosted by MIT, but you got to use MIT App Inventor. That shows you how great the platform is. Very great. It's great, right? You can do that. So that's the 3 directions. Okay, and if you furthermore, if you want to say, hey, what's next step? Okay, so well, that's a good question, because usually we talk about the next step. If you project further, further, I want to say probably, well, there is a whole lot of things you can do. Let's say this way, there is no single, absolutely, chance are unlimited. But one thing I can recommend is you can scale up to both software and hardware. I know some of you, I heard, you have background about like a single chip board control experience, right? Like Arduino, Raspberry Pi, ESP32 or something. That would be great if you put them together to do a comprehensive project. That would be very impressive. Like, so, okay. I want to say one thing, right? I know you are. Most of you. You are all so smart. I'm so impressed. I think one thing is very important. We do a lot of humanity education. We do a lot of like a STEM education. But one thing I want to emphasize is the winning is the ultimate, action, or it's something existence in your life. Okay, no matter what you say, I like, if you know Vince Lombardi, that's a guy who, as a baseball coach, is the most famous baseball coach it's probably in the history. Let's say it this way. That's what he said over here. He said, winning isn't everything, but wanting to win is. This is a very important thing. That's why you spend spare time. Even in the summer, in the summer, you take different classes. You want to do something. So I think that's very, just you guys need to remember that. Okay, wanting to win is everything. Yeah, no matter what. Okay, no matter what kind of education you receive, what kind of value you hold, but this always holds true. Okay, so one more thing I want to share with you is some further study material. Well, it's not formal, but I do know, just like I said, okay, at one time, whenever you exit to some classes or something, right? You wrap up something, you win something, you finish some classes, you graduate from some school. The most important thing is not to celebrate, but celebrate is important. But let's say this way: celebrate is important, but the most important thing is to determine your next step. That way you can go further, right? Okay, so yeah, I have just one last slide. I just want to share you. I'm not gonna say anything on it, but just give you some just a recommendation of some classes you can take. Oops. Can you see my slides over here?
Yes.
Right. Okay. So if you look at here, let me, I don't know. Yeah, maybe I can open this hyperlink. Can you see my web page? I don't think you can. Probably I share some like, let me share my desktop so that you can watch it. Okay, so here is it. This is a Coursera. This is a Coursera. Okay, so let's say this is a Coursera. It's a class. It's an online class, right? As Kevin said, the next step you probably can jump into like next step in AI if you decide to go that way. Don't know why they put it some Chinese, but this is actually the very famous the guy. It's Andrew Ning. I think probably you guys know him, right? He's so famous in machine learning and deep learning. Look at here, he has so many. How many students he has? I think he has like a, this class has been taken by like over 1 million students, and probably, this is a huge successful class. And this is not really, well, this is probably a good a good class you can study after that if you wanna study more. Look at the terms. That's so interesting, right? Look at the terms. Many of you has already touched, isn't it? Look at what you're gonna learn. I mean, the little description, and look at the words. I mean, the keywords that displays on that. You should be kind of familiar with it, right? Within our like a 1 week class, it doesn't teach you everything. It gives you what? I mean, if you've taken Kevin's class, what you learn? You're probably gonna learn. I would put a. I want to put the words like a map, right? So it is not something like you can do everything, but it's a map that you know where you are, and you know where the direction you want to go to somewhere. I mean, from one place to another. Say you want to go to Dallas to New York or maybe San Francisco. You know which way. I mean, you got a direction on that, and you know where you are. So, I mean, to do this artificial intelligence, absolutely, it is not like a 1 week effort. It's probably like several classes for college requirements. It's probably, I mean, as a researcher, you're probably gonna dedicate like so many years, right, to do. Okay, so this is one class. I think this is a pretty suitable one. The guy is, and he is a Stanford guy. He's such a famous guy. That this is one thing. The second thing I can say is, okay, look at the open courseware at MIT. They are all free, right? You get a course of machine learning and artificial intelligence. I put two links over here. So that's something you can take them. It is MIT first year students. I mean, I think it's for undergraduate, MIT undergraduates. There is another very famous one, but I don't think it's free. I checked it out, but they have some materials. It's free, but the class is not free. I mean, the video is not free. I don't see that, but it's a Stanford 230 and 231. It's so this is also like probably. Let me tell you one thing. One day I told them MIT, I mean, machine learning class has over 1,000 students, and the guy from Stanford told me, yeah, I'm taking like a 231. I mean, this is 230, and there is another one, 231 after this. There were like 1,700 students. they split it into several halls. I mean, it's not several rooms, right? Yeah, so a lot of people taking this one. Okay, why I want to mention this? Uh, it's actually the lecture, I mean, the instructor is the same as the Coursera. I mean, engineering, Professor engineering, right? So that's number one. Number two is some high school students, I know many of you are not high school, you are in the middle school. If you are in high school, if you can take this class in the summer and see whether they offer this class in summer, you can take it as a challenge. Okay, that's a good proven. It's a good proof that your capability, that you can take it. I mean, Stanford may give you like a credit. It's a true credit, right? So, but anyway, their website provide a lot of like a good information, like a project. Like every time I look at this, the students do a class projects. Oh, they're all very cool. Yeah. Okay, there is another thing is IC. I call it IC. It's a association of young scientists and innovators. That's the founder. Kevin and me are the founder of this organization, but now it's operated by current officers. I mean, of the current officers, 6 of them are Indians, 1 Chinese, 1 Korean. Yeah, so, well, there's just some students. It's pretty like, I mean, they are all very good, like very good guys, very achieving guys. You probably know that. So well, they have a summer camp. If you look at here, they have a summer camp. They're gonna teach like a Python with artificial intelligence. I mean, deep learning. I mean, machine learning, let's say that's way, machine learning. So if I, oops. Yeah, if I open it. So yeah, so just remember this. I'm gonna send the links to you. You don't have to, to remember this, but they do have a summer program. I mean, summer, they call it summer coding camp. This one is developed by, let me see. Yeah, me and Kevin, and well, actually I had a group of people developed this last year. If you look at here, yeah, okay, I'm a little bit, the display might be a little bit messy, but you can see that. So this is last year I developed a program for the summer, right? It's called the Summer Coding Institute. So what we have is we have a whole bunch of guys over here. This is the advisors. All these are professionals. Then we have like a lawyer. If some of you know him, yeah, we have lawyer, we have entrepreneurs, senior, I mean, executive in the company, scientists, maybe professor, and even so all kinds of expert. They approved this program, this program, and what they have is, yeah, they invited the high school. There's a high school students, right? So they're to teach this class as a volunteer. It's kind of volunteer teach this. Okay, this year. So, well, if you look at here, this is some like a description of what they're gonna do. And if you click on any of the links, let's say you click on the links, there is a master document like you have, right? You guys have. We have everything here. So this year they're gonna do the same thing. However, to be honest, I'm not really sure the quality of that camp because Kevin and I are not involved in the execution, but they're gonna use it pretty much the same I mean, courseware. Yeah, they're gonna, but however, they're gonna invite like a new people. I don't know. I heard like Kevin gonna give one lecture on that class. you can consider it, but the quality, I'm not sure, but you can take it, right? You can take it. You can consider to take it, but if you want to make sure you learn a whole lot of things, you probably can consider. Depends on your level, your self-assessment. Let's say, probably. I mean, the first two, I can recommend without any hesitation, right? Because they are all proven great courses. So that's all the information I wanna just give it to you. But the IC camp, the good thing is you can have a lot of discussion, interaction with other students. You don't study alone. You can talk with people. You can talk with even the most talent guys. The students like you guys, right? So that's the good part of the IC as well. So the last but not the least is I want to say, you guys want to. One thing is, okay. It is very important for you. Okay, how to be, be kind of, if you want to be, how to be successful in the future, right? You're gonna be notice one more thing. So here is something that's very similar to my idea. It says strength lies in differences, not in similarity. What does that mean? I think if you are valued by the society, there is two things you're gonna keep in mind. One thing is the uniqueness. The uniqueness means you're gonna develop something that not very unique, right? Not a whole lot of people have it, right? That's number one. Number two is your skills has to have what the impacts can have impacts, significant impacts on our society, which means people need it, people can use it. Right? So that is very important. Okay, so this is gonna give you something when you think about, hey, excellence means I got a high GPA, is that right? Or, well, it's a component, but not everything. So if you want to be, when you pursue like excellence, I think this is important. Okay, remember this. Trying to find something in differences that will distinguish you from others and help you to be successful. Okay, that's conclude this class. Any additional questions before we can close it? Okay, if not, we'll finish it. Okay, so yeah, goodbye, everyone. But don't remember to submit your homework. All right. Okay, bye-bye.
Thank you.
Kevin.
Thank you.
Thank you.